This RC Beginner Series is brought to you by Horizon Hobby. Hey, welcome to Flite Test. I'm Josh, and this is Josh.
Hi.
And this is episode 6 of the Beginner Series.
It's already up to 6.
That's right.
It's amazing.
We're more than halfway there.
And
you
friends,
are almost a pro.
This is a meat and potatoes episode. This is a hardcore information, so play it over and over again because we're going to cover a lot of stuff.
Yeah, today we're talking about power systems.
Power systems. And you know what? The key to remembering things, power systems, is the prop. But there's a lot more than a prop to power systems. So we're going to talk about the propeller.
Okay.
We're going to talk about motors.
We're going to talk about the speed controller.
Or ESCs.
Yeah, and then there's also batteries, but we're going to talk about that in another episode.
Yeah, but it's part of the system, so we got to cover a little bit of it here.
Yeah.
And
now, it's very important that we start with the prop.
Yes.
And kind of work your way back, right?
And also that we start with a little bit of reading, too.
Okay.
If you're going through this, the whole beginner series, like we hope you will be following, it starts with a reputable manufacturer, a reputable plane, and hopefully that means reputable documentation. Everyone that is reputable, see I said that word again?
You love that word.
I love that word, will give you a prop size or a motor size reference. That's where you're going to want to start. And speaking of props, we got different kinds of props, different materials that props are made out of.
Yeah.
And let's just start with trainers. If you're having a trainer, most likely it's going to be electric. And there's a wide variety of different electric props.
Boogie, woogie, woogie.
Now, hopefully, if you're starting with electric and a good trainer, you're going to be flying something called an electric slow fly prop. Now, the neat thing about this,
it's bendy.
Crazy bendy. It can take a ton of beating and still keep on ticking. But you know what? Look at the price of this prop.
$175.
No, it's $175.
Oh.
There's no reason to try to save your props. If you have any white stress lines or any sign of damage, any cracks on the tips,
get rid of it.
Get rid of it. It'll cause balance issues, it'll cause performance, and the last thing you want is one of these flying off and hitting somebody.
Ouch.
So just don't do it, okay? But you got electric slow fly.
What about that wood one? What's that about?
There's wood for gas and also electric, but predominantly on gas airplanes, you're going to see wood props.
Okay.
All right?
Old school.
Some multi-rotors will carry wood props.
Okay.
Yeah, old school.
What's that one?
This is a combination plastic. It's much stiffer.
Uh-huh.
And much more durable, but this is for electric. Now you're going to notice if you have a gas version of this, it's going to be much thicker around the center area. The reason being is that those compression and power strokes actually cause it to torque.
Whoa.
So you don't want this area fracturing. So the gas style props will be much thicker and much meatier in the center. You see that?
Yeah.
Pretty cool stuff.
That's beefy.
All different types. There's even carbon fiber. There's fiberglass props. Tons of different makes and everything. Just make sure if you're flying electric, pick a prop for electric. If you're flying gas, pick a propeller for gas.
And read up on it.
And read up on it.
And if you don't have a manual available, you can always go on the internet. There's lots of helpful forums and all kinds of stuff where you get good information.
And there's also good information on every single prop, and that is the numbers.
Yeah.
Okay, you got 2 sets of numbers on the props. I'm just going to pick on the wood because it's easiest to find, but also the numbers will either be close to the center hub here or printed somewhere on the propeller.
Now the first number is the diameter of the prop?
Diameter, you got it. And it's generally in inches. Some props have it metric on the other side, so you can see here, 279 by...
That's clearly not
crazy.
inches.
Yeah, it's a lot easier to call it an 11.7.
Okay.
Okay, so as you said before, the first number is diameter. The bigger you go, the bigger the diameter of your propeller is.
What's the second number?
That's where it gets a little complicated. That's the pitch.
The pitch.
Now, the higher the number, the more pitch or the more bite your prop's going to make into the air. Exactly. But you know, there's a trade-off with there. Higher pitch will give you higher speeds, but less efficiency at lower speeds. So that means you got to get your plane going fast before you ever feel the effects of the propeller, efficiently.
So the pitch is how far forward it's going to travel every time it swings around?
A 4 pitch will theoretically make it travel like 4 inches through the air.
Okay.
8 pitch would make it travel farther.
8 inches through the air.
Exactly.
And then
exactly.
a 9.
And that's in a perfect world. You're not
10
gonna.
would be 10 inches.
You're not going to get that exactly.
You go on from there.
Yeah, but a lower pitch prop will give you higher thrust but less speed. So generally what you'll see on a trainer is a lower pitch or a slow fly prop.
Okay.
You'll see 3.8, 4.7, maybe a 5, but once you get up past 5, you're getting into the standard high-speed prop range.
Okay.
Okay?
You got it.
All right, so always check your manufacturer's specs for that. Now, we said it all starts with the prop, right?
Yes.
That's because this is the load on the motor.
It's at the front.
Exactly.
Start at the front.
So we know what size prop we need from the recommended manufacturer specs. Oftentimes, the manufacturer specs will also talk about the motor.
Okay.
Say this needs a 1047 on a 400 size motor. Okay, so there's lots of different specs that will be included there. Electric motors are also rated in different ways. You can have the stator size, the glow equivalent, or the power and the weight.
Okay.
So in the case of this, the stator size, imagine a motor is a 2409. That would be 24 by 09. Okay, that's talking about the size of the stator. Bigger the stator, more power.
Right.
You can also have the glow equivalent, like a power 10. And a power 10 is talking about the old glow engines, and basically this is the same matchup for this plane. So say you had a power 10 on or a 10 size motor on a plane, you can put a power 10
Okay.
Exactly. So we
Gotcha.
talk about it that way. Now, there's two different types of motors. Do you want to guess what they are?
Brush.
Yes.
And brushless.
Yes.
What does that mean?
Brushless is where there's no brushes physically making contact with the stator. Brushed motors.
The stator's that thing in there?
Brushed motors used to have the springs pushing little contacts there, and it actually had to have friction between it.
Okay.
Wasn't the most efficient, but it was the most common.
And brushless uses magic?
Brushless does not use magic. They actually energize fields of magnetism around the motor to cause it.
So it spins more freely.
Exactly. Much more efficient, much quieter, and also less maintenance, too.
Okay.
These suckers are waterproof, as long as it's not salt water.
That's cool.
But the easiest way to tell brushless versus brush is brush motors will have 2 leads.
Okay.
Brushless will have 3.
Okay.
Now, if you have a brushless motor, you need a brushless ESC.
Okay.
All right? So you always keep in mind of that, and always read the specs. They don't just put words on papers for no reasons.
Right.
So if you read the manual and read the specs on each individual item, it's always going to guide you to the next most efficient, because if you're buying a motor, they're going to say the best ESC is a certain amperage rating to power this, okay?
Okay.
So just keep following that line. Always keep reading. It's not intimidating, and if you go along the line, you'll have the best setup.
So your prop connects to the motor right here.
Exactly.
And
there's a very important thing about propellers. We talk about pushers and pullers, right? Your tractor and pusher.
Yeah.
There's numbers on this prop we talked about earlier, right?
Yes. Yeah.
Numbers always go forward. If the plane's flying forward, whether it's on the back of the plane or the front of the plane, always make sure the numbers are pointing forward.
So when it's on the front, the numbers obviously go forward. But when it's a pusher,
yes,
it's still facing the same direction,
it's still
right?
facing the same
so
direction.
even though it's on the back of the plane, these numbers are going to point forward.
It'll still produce thrust if you put it around, but it won't be efficient. It'll be high amperage draw. It'll be noisy. It just won't be good.
Okay.
All right?
Right.
Now, there's 2 different types of motor configurations, too. We have brush and brushless as the types of electric motors, but there's also
outrunner and inrunner.
Exactly.
Okay.
An inrunner motor will predominantly be found on faster flying, like maybe flying wings or your striker, things like that. That's where the actual center. It looks a lot like a brushed motor from the past.
Just this guy right here is the only thing that's spinning.
Moving. You got it. Everything's
That's an
internal.
inrunner.
Yes, usually higher RPMs out of the inrunners. Okay. Now,
faster.
Outrunners are generally lower RPM.
And the whole thing is spinning.
The whole entire outside is spinning. Just as we pulled it apart, you can see that the bearings are on the inside, the stator's there,
right,
and that the whole outer bell actually pivots with the prop. So the prop is actually fastened to the outer housing.
Okay.
It's great for cooling too. Now, motors are also measured in a lot of different configurations. There's kV rating, there's power, and then there's actual size. Okay, and those sizes, as we talked about before, that's the size of the stator, the weight, those kind of things.
The actual physical size.
Exactly. But there's also the power. The power is measured in watts.
Okay.
Okay, the higher the wattage, the more power you're going to produce from there.
Right.
And there's also something called kV. Do you want to take a guess at what kV is?
Kilovolts.
Kilovolts?
Yeah.
It sounds like kilovolts, and there are kilovolts out there, but not in this motor. It's actually RPMs per volt by the thousands.
Where does the K come from?
K means constant.
Somebody needs to tell these people that constant starts with the letter C.
I know. We'll put out a memo. Maybe they'll change it. But right now it's kV. It'll probably always stay kV. But just think about this. If, say, this motor right here is a 1010 kV motor, but say it was 1,000 kV. Let's just keep it simple, okay?
Okay.
And we're applying 10 volts to it. That's going to give us 10,000 RPMs.
That sounds like math.
Now, here's the key thing. It has nothing to do with power. It has only to do with rotation. So don't think, oh, I'm going to go to a higher kV motor and get more power out of it. You're not going to get that because the higher kV motors require smaller props.
So a motor could have any one of those 3 different kind of specifications.
Exactly. And if you dig deeper, they'll oftentimes give you a thrust or a wattage and a weight. Yeah, equivalent. Now, there's a great calculator out there that we're going to have linked to below. Our goal here with the beginner series is give you the information, then point you towards other avenues that give you much more information when you need it, not just to bombard you with tons of information. So there's going to be a calculator below. It'll show you how to select, if you don't have these specs, the perfect motor with the perfect performance and the perfect prop. It'll all be below, and it's dynamic too. That means you can change one number, it'll give you different specs on the other end.
There is an app for everything.
Yeah, a lot of amazing people put work in this. We definitely want to show it so you guys can benefit from that. So look for that app. It's an e-calc system.
Moving on back, next is the ESC.
The ESC tells the motor what to do.
Oh, yeah?
Yeah. And what do we talk about with brushed and brushless? Will a brushed ESC match up with a brushless?
No. You gotta match those suckers up.
The ESC is what powers the motor, but it has to be strong enough. It has to be able to deliver the amperage. So there's going to be an amp rating on the ESC.
All right.
Okay, so as we talked about, the prop chooses the motor is going to choose the ESC. Say this motor requires a 30 amp ESC. Would we want to put a 25 amp on it?
No.
We probably truthfully want to put a 35 amp ESC because we want to run it within 80% of its capacity.
Okay.
Okay? So we always want to make sure that our ESC can deliver enough amperage without blowing up.
Right.
It's embarrassing. You get the blue smoke that never comes back. It's bad stuff.
Doesn't sound good.
So always keep in mind when they give you the specs on your motor, what kind of amperage it requires, listen to it, obey it. And oftentimes try to use the 80% rule. Use 80% of its capacity. So if it's saying 25 amps, go to a 30 amp ESC.
So why don't you just use like a big 80 amp?
80 amp?
Yeah.
Well, let's take a look here. This motor here requires a 30 amp ESC.
Uh-huh.
That's the size of a 30 amp ESC right there.
Right.
Pretty small, right?
Yeah.
It's also pretty darn cheap.
Okay.
An 80 amp, this is a 60 amp. Look at the size difference just going from 30 to 60.
Big boy.
Yeah, and it's not going to give you more performance or more power. It's only going to supply the motor with what it needs and what it's asking for.
Okay.
So don't think you're going to hop it up by hopping up the ESC. You just add more expense and weight.
I don't hop anyway.
You don't hop?
Not too much.
This doesn't have chrome valve covers, my friends, okay?
Okay.
Okay. But there's also other specs on the ESCs as well, too. There's the voltage requirements. ESCs can handle different cells or different voltages of batteries. So if you look at the specs here, this will handle a 3 to 4 cell lithium polymer battery.
Yeah.
Okay. Or 9 to 12 cells nickel metal hydride. Not many people fly nickel metal hydride. So just make sure when you're reading this, if you see 9 to 12, it's not meaning LiPo. Make sure you see LiPo battery or light lithium polymer battery.
Okay.
Okay, afterwards.
So you don't want to get too big of a battery on your
Exactly.
ESC.
This is a 3 cell here.
Okay.
Totally happy operating there.
Right.
This is a 4 cell. Still good. That's a 6 cell.
6 cell.
Puff.
No.
Boom.
Puff the
Bad
magic
things
dragon.
happen. Yeah. Bad sparks will fly. Okay, so just listen to that. Always obey what it says.
Yes.
And there's also different
sir.
things. You got that?
Yes, sir.
Okay. Want to talk about BECs?
Sure.
Speed controls will either come with a BEC, which is a bladdery. Now, every ESC will come with something called either a BEC or no BEC. Remember what BEC stands for?
BC is Battery Elimination Challenge.
No, circuit.
Circuit.
Battery elimination circuit. Basically, this little guy right here is supplying voltage to our receiver. That's generally between 5 and 6 volts.
Okay.
Okay, if it doesn't come with that, you need an external BEC. We talked about that in the previous episodes. I think episode number 3, if I'm not mistaken.
It's so long ago,
Yeah.
I can't even remember.
Go back and watch that. But just keep in mind, no BEC means you need an external BEC.
Okay.
Okay?
Now, what would happen? We have this whole setup going
Yeah.
here. What if we have everything set the way we want it, but then you want to put like a bigger prop?
A bigger prop or even a pitchier prop, maybe?
Yeah.
Okay, a higher pitch. Remember we talked about how the prop is the first thing that changes everything.
Okay.
You go to a bigger diameter or a bigger pitch propeller, you're putting more load on the motor.
It's going to pull more.
Exactly.
Okay.
It's going to pull more. It's going to try to work harder, but you're also making this work harder. And when this works harder, what's it going to do? It's going to ask this to work harder.
And
so
then-
you're going to draw more amps.
And then,
Exactly. You have a serious chance. If you go too big on your prop or your pitch, or you go out of spec here, it doesn't matter if you had a perfect, efficient system before.
Yeah.
You could possibly burn up your motor and your speed control, or even damage your battery. A watt meter is going to be wonderful for that. A watt meter is going to tell you how many amps you're drawing and how many watts you're producing. Two very crucial things. The watt's going to tell you whether you're getting more power out of the plane, but the amperage draw is going to be very crucial to make sure that you're not overwhelming the battery,
Okay.
the motor, or the speed control.
right.
Okay?
Okay.
And speaking of batteries, we had this whole setup here. If you're following the manufacturer spec from the beginning,
Yeah.
it's going to recommend a battery. Okay, so like say a 2200 3-cell. That's going to deliver enough power if you're using their stock setup. But if you're not, you're going to have to be very careful. But don't worry, we have our next episode coming up is going to cover that
We're
in
going to
great
talk
detail.
about batteries, all these
Yes.
different types and sizes of batteries.
So you got to tune in next week to go in detail with that. But just
That's
stay
right.
the specs right now, you'll be in good shape.
Okay, but first, let's sum it all up.
Recap time.
Now you got to start from the front.
Yes.
Start with that prop.
Yes.
And there's
props,
lots of different kinds of props.
There's
but
gas props, there's electric props, and props have different numbers that mean different things.
yeah, the first number means the diameter of the prop, the size of it.
Yep.
And the second number is the pitch. That's how far forward it's going to go as it turns.
The smaller the number, the more thrust, less speed you have. The greater the number, more speed, less efficiency at low end.
Right, and always make sure that the numbers are facing forward. Whether you have it on the front or on the back of the plane, make sure that those numbers are always facing forward.
Exactly. And we have motors. We have two different types of motors.
Brushed and brushless.
Yep. Brushless are more common, and you can always tell brushless because they have 3 leads on them.
Right.
Okay, different ways of telling your power setups on your motors. That's going to be through the actual size of your stator,
Right.
or a glow equivalent,
Okay.
or even the weight and the wattage produced.
Right.
Okay?
All right. And there's two different kinds: the in-runner and the outrunner.
Exactly. Outrunner, the outside spins, the housing spins.
The in-runner is just the shaft that spins.
Just the shaft. Exactly.
Okay.
Every motor is going to demand a certain amperage. That's going to be provided by your speed control.
Right. Which is right here.
And once again, you got to match brushless speed controls.
Match, match, match.
Like brushless motors. You can't cross-compatibilize
That's
them.
right. The prop picks the motor, picks the ESC, picks the battery.
Some
You choose
ESC
your friends. Don't let your friends choose you.
Exactly. Your ESCs will be able to run a certain amperage, but also they require certain power from your battery. That could be 3, 4 cells. Always read how many cells or how much power your ESC can handle.
Okay.
Okay?
Is that it?
I think that's pretty much it.
Okay. Well, we want to thank you guys for watching, and thanks Horizon Hobby for sponsoring this episode. And if you guys haven't seen our earlier beginner episodes, make sure you go back and check them out. There's lots of helpful information, and we always have lots of helpful links that you can go to, all kinds of different stuff to give you lots of
Especially that e-calculator. That's great for newbies and experts. And there's also a lot of great links, too, that'll go into this detail much further. But there's also podcasts,
Yeah,
too.
our podcast. I think it was episode 3.
Yeah.
We went into some more detail about motors in that episode, so make sure you check that out as well.
And we're always going to try in future podcasts to have some technical data there, too. So
Nice.
keep on top of those.
All right, we'll see you guys next time.
Next time.